All right, let's practice connecting some arrows tip to tail. Now this problem is, let me just look at our homework problem. So our homework problem has two arrows that are 100 pounds and 200 pounds. I'm going to do one that's 8 pounds and 16 pounds. And I have drawn them at the right angles. We're going to come back to the angles, but for right now, let's just look at these. Okay, now I would like to find the resultant of those two arrows. What force has the same net result as those two individual arrows? Let me suggest that when you draw your forces, you just save a copy of those and don't mess with it, and make another copy of your arrows someplace else, which I'm going to do, so that if you mess up, you've still got your original. That's always good advice, no matter what you're doing. Okay, so here is my set of arrows, and I can go tip to tail. So let me take this short arrow and move it. So I'm using the move command. What base point do I want? I'm going to grab it by its tail right there, and I'm going to move it, hook it up to the tip. Okay, there we go. Now I'm going to get I'll get on another layer. Now I'm going to find the resultant. And to find the resultant, I'm going to go from the start point, head off to the end point, and there is my resultant. I just drew that arrow by hand. Now, let me see what magnitude that is. I could find the magnitude a couple different ways. One, I could use the aligned dimension. I have no idea whether I set my scale properly or not. I probably didn't. Aligned dimension. Okay. So this arrow is 13.856 pounds. Or I could do the distance command. Now up here in your toolbar, over here under the utilities, are some handy measure tools. And one that I like is distance. And you might think, oh, the first letter in this word is D, D for distance. That's going to turn out to be some other command. But if you type the first two letters, DI, you will get distance. Or you could just click that command line. I'm going to be cool and type DI for distance. Click one endpoint, click the other endpoint, and look, down at the bottom of the screen, it spits out the distance is 13.856. Ha! That's what I got with my dimension, so that's good. Now I will measure the angle. I'll use an angle dimension. Angle dimension. I'll click on my resultant. I'll click on my zero line. And I'm at 50 degrees. All right, there's my resultant. Now I got that by doing tip to tail in this order. I could have gone in a different order. Let me try a different order. I could make a copy of these guys. I'll come up here somewhere. Well, no, yeah, I'll come up here. And now, this time, I will take this long line and I will stick it onto this short line, also tip to tail. Now, when I start at the start point and head off to the end point, there's my arrow. And look, that line is also, hello, angle command, 50 degrees. And I betcha it's also 13.856. What do you bet? Yes, it is. So I got the same result either way. All right, so that's fine. Now let's look at our homework problem, which is this. And these lines are longer, 100 pounds and 200 pounds. So let's do a couple of things. First, let's check our Osnap settings. We really want as many Osnaps available as we can have. Endpoint is especially useful. Perpendicular, intersection, nearest, those are all good. So we want to have all those Osnaps turned on. That's my suggestion. Okay, and I'm going to draw a line, just a nice horizontal line. To get a nice horizontal line, I like to turn ortho on. That's right down here. I think that's handy for making a line fast. Okay, now I'll turn ortho back off. Ortho just restricts you to horizontal or vertical, is what it does. And notice, if you hover over it, it tells you, see that F8? If you push the F8 key, that also will turn ortho on or off. Okay, now let's draw our first line. I'll draw my first line at a 20-degree angle, 200 things long. Right. So my first line, I like having that nearest endpoint Osnap, see that little bow tie thing? So I can click any place on this ground line and know that I'm hooked up. Okay, now I have my dynamic cursor turned on. That's those boxes stuck to the cursor. And I want a line that's 200 things long at an angle of 20 degrees. Oh, look how far out in space that's going to be. That's a big one. So maybe I want to zoom way out. Now I'll make my line. And to enter these numbers, when you have your dynamic cursor thingy on, one box is highlighted. See that white box with the blue? That's the distance, and I'm going to type 200. Don't hit enter here, because enter will accept the whole thing and kick you out. So here, click tab over to the next box, where you now have, it's kind of buried by that, that's handy, kind of buried by that other thing. Now this other box is highlighted, that's where the angle is, and I'm going to type 20, enter. All right, good. Now, let me move this over a little bit. Okay, now our other line is 100 degrees at a 40-degree angle. But watch out, this is tricky. I'm going to come over here and I'll draw, maybe on a different layer, line I'll make it 100 things long, and then I'll tab over to the angle box. But what is going to happen if I enter 40? I'm going to be way the wrong direction. I need to be 40 degrees off of horizontal over here. Okay, so, my friends, what is 180 minus 40? 180 would be clear over here to the side. I want to go 40 degrees less than that, so I want to go 140, don't I? 180 minus 40 is 140. Enter. There's my line. So you can see why we were talking about reviewing geometry earlier. Okay, now what about those arrows? Well, this is the annoying part of doing these forces. There are different ways to do those arrows. One thing you could do is just zoom in here and make some lines. But now if you try to pick up your vector line, these arrows don't come with it. So you have to make, if I try to move this line, the arrow doesn't come with it. So you need to be careful about grabbing that. Another thing you could do, let me erase these. You could use a polyline if you're feeling adventurous. A polyline will make the thing all one length, and what I sometimes do, to be honest, is I get a polyline, I trace over the top of this thing, and then if I click on it, the whole thing is all one length. So that's another thing you could do. Or another thing that is kind of stupid looking, you could get a leader and start, leaders go upstream, so you have to start at the arrow end, come back down here, but then that's kind of a problem, yes, because now the arrow is a little tiny thing. Ooh, look at that miniature. And I think the leader is not actually a line that you can measure, so that's annoying. So, oh, and another thing you could do, you could also maybe just do a polyline, but just come out here. Stop that. You could just do a polyline, come out here in space, and make a dorky looking arrow like that. That's perfectly fine too. So arrows are the annoying part of these forces. One other thing I want to say is these forces are really long, and it's okay if you draw them to scale as long as you keep the numbers right. So you could draw these 1/10 as big. You could draw an arrow that's 10 units long and 20 units long as when you are done, you write the correct number. So I could go, oops, let me make a horizontal line. I could go one line that's 20 units long, tab, at an angle of 20, and I could do another line that's 10 units long, tab, at an angle of 140, enter. So that's 1/10 the size. That's okay though. Now managing the arrows and the text and stuff is easier. As long as I remember to write the correct number. If I get 173, if I get 17.3 as my answer, I need to write 173. If I get 17.3, I need to convert that to 1.